Now, I know that most of you probably know me. I'm Dr. Greg Jicha. And many, many years ago, we started this exploration. And we really thought, that as the data really just fully came out this spring, and we're still actually doing some analyses on it, everybody always wants to know whatever came of that study and everything that we went through. And I think this is a good story. So I presented this in Los Angeles for the first time for an international audience anyway. And we're going to kind of walk through those, what I presented there today. And I'll kind of try to break it down, hopefully, so that you all understand the importance of your contributions to research, because I think this is going to be incredibly important for the field. So this study was funded by you, by your tax dollars. So it wasn't just that I asked you to come in and get pictures of your brain and take memory testing and have a spinal taps, but you actually paid for your own torture. Isn't that wonderful? You don't just ask the NIH for money. You have to present to them the concept of why you think that this is an important thing to do. So we'll walk through that from the beginning all the way up to the results, and then talk about anything you guys want to talk about. So we do know that there are certain medications that are out there that have been used for years and years and years, that have been developed for one reason or another, but then we find, wow, this is a great medicine for something else. That's what we call repurposing of medicines. So some of you may have heard of a peripheral neuropathy. Has everybody heard of peripheral neuropathy? Diabetics and other folks can get this, and it can lead to burning in their legs. Well, there were no good medicines for peripheral neuropathy. And then a seizure medicine was developed, something called gabapentin or Neurontin. And it turned out it was a really lousy seizure medicine. But everybody that was in the studies for it that had a peripheral neuropathy said, well, it's not doing a darn thing for my seizure, but boy, my legs feel better. And it has become the most widely prescribed medicine for peripheral neuropathy in the world. So this is kind of a story about repurposing of a medication, not Neurontin or gabapentin, but a medicine that we know as what we call PPAR alpha agonists. And they are more commonly called fibrates. And fibrates were one of the first cholesterol and triglyceride lowering medicines that were ever developed. And so looking at this link between cholesterol and Alzheimer's disease has really been an area of very active interest over the years. And when we look at studies particularly that use fibrates, what we can see is that there's almost a 60% risk reduction in people that had taken fibrates, and these came from two studies in Europe, the Tri-City study, which is in France, I believe, and then a large Italian study of the population. And it never really was explained. And so people have thought, well, why would people that have taken a fibrate have such a reduced risk for the development of dementia or Alzheimer's disease? And so people have looked at it. And on the right side of the screen, you can see some different properties of the fibrate. So one in blue is their lower your lipids, your cholesterols and your triglycerides, and they also improve your body's ability to use sugar, essentially kind of reversing subtle diabetes. There is reduced inflammation in red, and so people have known that these reduce inflammation in the body. In yellow, reduced oxidative stress. Oxidative stress is kind of rust in the body. It's damage to proteins and DNA and fats that is very age-related, but also many toxins increase oxidation and are harmful to us. And then in green, proposed anti-Alzheimer's disease actions. And these are actions that have been looked at in mice models and in cells in culture. And people have said, well, boy, you know, these medicines may actually reduce amyloid that forms the plaques in the brain, and they may reduce abnormalities in tau, what we call tau phosphorylation. That is something that is important for the development of tangles that eventually destroy nerve cells. So many years ago, so this is a paper from 2008, so now 11 years ago this was first published. This is a study done from folks that are or were in our longitudinal research program. This is an autopsy study of folks that have passed away. And it was looking particularly at what's called a microRNA. Now, microRNAs are really, they used to be thought to be junk and just junk DNA. And maybe you all have heard that before, that the average person only uses 10% of their DNA. The other 90% is junk. Well, you know, we really don't have any junk in us. If we didn't need it, we would get rid of it and lose it. So these are not what we call non-coding little fragments of RNA. And for years we didn't understand until about 2001, we did not understand what these were whatsoever. Our neuropathologist, Dr. Pete Nelson, actually is one of the first leaders in the field of microRNAs. It turns out that they are important in turning on and turning off health and disease pathways in a variety of different disorders. So there are hundreds of microRNAs that are discovered. But Pete was very interested in this microRNA 107 because when he screened microRNAs, and there are 4 types of patients here in light blue, there are people who were normal, cognitively normal, good memory and thinking, and at autopsy they had no signs whatsoever of Alzheimer's disease. In purple, we have people who were completely normal in their memory and thinking, but they already had plaques in their brain. The green triangles are people with mild cognitive impairment, mild memory problems, but still doing everything. There's probably a bunch downstairs in the library right now picking out a buck. And lastly, the group with mild Alzheimer's disease in the red or brick-colored squares. And he measured microRNA 107 levels and found that, yes, they're much lower in Alzheimer patients than they are in people that are aged but healthy and normal in their memory and thinking. But what he also found was, even by the time the mildest memory problems come about, the microRNA levels have dropped. And even in people who still have normal memory, if they were building up Alzheimer plaques in their brain, the levels in purple were reduced. So this led Dr. Nelson to begin thinking about, why do microRNA 107 levels drop at the earliest signs of any kind of Alzheimer type change in the brain? And so he tracked down that microRNA in a series of experiments and found that this little tiny fragment, this little microRNA 107 up at the top, HSA MIR 107, it sits inside of another gene, what's called the PANC1 gene. And the PANC1 gene is important for metabolic health, general health, low sugar, low cholesterol, healthy folks. And that this gene could be turned on by what's called a PPAR alpha agonist, a fibrate. And the fibrates, as I showed you earlier, have been used for about 30, 40 years. They're primarily used in Europe. Their use is much less here in the United States. But Pete figured out that if you increased PANC1 gene expression, you would raise the levels of microRNA 107, essentially doing the reverse of what Alzheimer's does with this microRNA. And so he was able, in the bottom graph in blue, he was able to show that if he added a fibrate, bezafibrate, to cells in culture, they would increase their microRNA 107 levels. Interestingly, he also looked at, well, what does the increase in microRNA 107 levels do? And it turns out that what they do is they shut down something called BACE 1. And I'll tell you a little bit about that. This is a very important enzyme that actually is one of the initial steps in turning on the Alzheimer process. Therefore, Pete's hypothesis was if your microRNA 107 levels drop, then instead of keeping Alzheimer's suppressed, Alzheimer's and BACE 1 is released, and we go on to develop the cascade. And in thinking that, he thought, well, if we can keep those microRNA 107 levels high, maybe we can never let the Alzheimer's switch turn on. So that's the scientific premise. So this is a little cartoon diagram of amyloid. Amyloid from its precursor protein, this piece of blue spaghetti here, is in all of our brains. And all of us are processing it. When the Alzheimer's switch is turned on, it turns on two enzymes, what we call BACE, beta secretase, and gamma secretase, these two little scissors. And they cut out that little green piece, and that little green piece is toxic to the brain. It kills nerve cells. And so the thinking is if we can keep this little green piece from being clipped out, we can shut down the Alzheimer process. That's exactly what we tried to do with this study. So this is what we put you all through. We had you guys come in and we made sure, that you were eligible for the study, and we took some blood and made sure that the medicine would be safe to give to you. And then we drew spinal fluid and took a picture of your brain. And we followed you over time to make sure that you were doing well. We did have a few people who had trouble with the medicine, and I'll show you about that. Nobody that was harmed, however. And all the way through, and at the end of 1 year, right, we had you come back, we repeated your memory and thinking testing, we sent you back for a picture of your brain, and we took a second spinal fluid draw so that we could compare in your blood, in your spinal fluid, and in your brain imaging, what was the effect of being on Gemfibrozil, a fibrate, for 48 weeks. So this is kind of what we did. So this is what the population looks like. And you can see, when you participate in research, we don't put your names up there on the big screen. I'm sorry about that, any of you that wanted fame and glory. We were in Hollywood anyway. But we don't know when the study's running. We did not know which medicine each of you were on. And you did not know which medicine, if you were on the medicine or the placebo. So we ended up having 75 people in the study. 35 received the active medicine, 40 received placebo. It was supposed to be a perfect split down the middle, but sometimes these things just don't work out right. Average age, about 73 to 74 years of age. No difference between the two groups. Of course, everybody in our program and most people that participate in research are very well educated and intelligent. So here, the average was more than a college degree. We looked at genetic status in the group, who might carry risk genes for Alzheimer's disease. We looked at what's called body mass index, a measure of general health. Males and females in this group, and that's kind of unusual. Usually we have more women than men by far participating in research for reasons that we don't quite understand, whether or not they're more altruistic or what, I don't know. But we had a very nice split here as well. Low minority participation, and that's a problem that is recognized nationally and something that we are working on in depth here at the university and in many national efforts as well. And then a split. The CDR is how many people might have had memory problems versus didn't. But the big point of this is that there was no real difference between the two groups. Now, we did look at safety as a primary outcome, always. And we knew this is a medicine that's been given to tens of thousands, probably hundreds of thousands of people over the last 30, 40 years. So we knew what to expect as well. There were we did have some folks that developed a headache after having their spinal fluid drawn. One person required a blood patch. That's when we bring you in, take you to the hospital, and have a little bit of your own blood squirted in your lower back. That subject, after donating their spinal fluid, said, "That's it, I'm done." And they actually never participated in the study after that, which is a shame. But giving somebody a bad headache is not a good thing to do. We try not to do that. There was one person in the study who developed some worsening depression and was commenting that they might want to just end it all now before they go on to develop Alzheimer's disease. We, of course, when they expressed that to us, sent them off to the emergency department for an evaluation. The psychiatrists in the emergency department thought that they were fine and sent them home with an increased antidepressant dose. We did have a few other post-operative complication. The depression, that was somebody who was on the placebo, not on the real medicine. We had a post-operative complication, had nothing to do with the treatment. There was a bladder puncture during a procedure. The person did okay. It was complication. They were on Gemfibrozil. We don't think Gemfibrozil had anything to do with that. We think the surgeon slipped. And then one case of pericarditis. That's an inflammation around the brain. And that we scratched our head on that one because from what we know about fibrates, they should reduce inflammation, not cause it. The doctors worked them up, this person up, and at the end of the day, it was determined that this was a virus, a viral pericarditis. They got better. We did have a few what we call TEAEs. These are treatment emergent adverse events. They're actually problems that we think these are due to the medicine. We absolutely think so. So we had one person who developed a drop in their white blood cell count. Not to dangerous levels, but their white blood cell count dropped. And they've had this as a problem for many, many years. The doctors have been following it. It's never been explained why he has a low white count. But when we saw it dropping even further, we said, stop your medicine. Let's take a look at this. We stopped it, rechecked his blood levels. His white count was back up. We restarted him on the medicine, had him come in a week later, and his white levels were dropping again. We said, that's it. You're out, you're done. We did ask him to stay in the study till the end so that we could analyze him with the rest of the group, but that happens sometimes. It's rare, but if ever in a clinical study, I see something that leads me to believe that you're being harmed by participating in the study, I have to pull you out and stop you. He was disappointed, but understood. Now, we worry about these cholesterol-lowering agents. They actually can develop inflammation of the muscles, what we call myalgia or muscle pain. And there's an enzyme, a muscle enzyme called CPK that we measure. And we did have two subjects that complained of muscle pain. Their safety labs were great. It showed no muscle damage, but they were having pains. We took both subjects off the medicine and said, that's it, you can't stay on the medicine because we don't want to wait until you have muscle damage. We're just going to stop. This is kind of something that can occur in folks. It occurred about 3%. And then we had a few other folks, one with a headache and one with itching at the site in the back where we drew spinal fluid from. So this was the major safety issue that we were looking at that we know with statins and fibrates and other cholesterol-lowering medicines. We know that worrying about the muscle is the primary concern. So here in light blue, we looked at the FDA data based on thousands, tens of thousands of people that have been in all the studies for fibrates, and then we looked at our study data. And what we actually found on the left is that the incidence of having these muscle aches is exactly the same as always reported. It wasn't more in our population than what was expected, again, about 3%. And the CPK levels were well within normal range. So the normal range goes up to 250. On average, our folks were 110 to 120, and no statistical difference between whether you were on placebo or the real medicine. So these are the safety features of the study. And this is really, really important, because if we're going to move forward with this medicine, we need to show first that it's safe. So we have two groups here, the treatment arm on the left and the placebo arm on the right. And we grouped people's complaints. You know, when you're in a study, you know, everything that happens to you, if you trip and fall, we consider, well, that must be due to the medicine until proven otherwise. And we don't know what you're on, so we just have to assume everything. Turned out we looked at musculoskeletal aches and pains, and they were actually more common in the placebo arm. I find that intriguing, and we'll get back to that later as well. Respiratory, coughs, colds, allergies, the same. Stomach problems, the same. Fatigue, tiredness, eye changes. We did see two folks that had complaints of vision changes or vision, you know, glaucoma or something else. Nothing that fits with the mechanism for the drug. Skin reactions, neurologic problems, psychiatric problems. And again, across the board, everything that we looked at here, it turned out had no difference between the two groups. We saw absolutely no safety signal. Now, for those of you that don't know, behind the scenes was a group of people called the DSMB, the Data Safety Monitoring Board. And the Data Safety Monitoring Board had a scientist from the University of Louisville. It had a doctor, an expert in lowering cholesterol, an endocrinologist from Ohio State University. It had a biostatistician from the University of California, San Diego, and one of his colleagues, a neurologist that specializes in Alzheimer's disease. And I think that's it. And that group of folks were privy to everything. Adverse events, they also, while they don't know who any of you are, only I do, they knew what your study number was. And so they were watching behind the scenes to make sure all the way along, not just at the end when we unblind everybody, but at the very end, that there was no safety signal. So it was deemed safe. We were very happy with that. One of the questions that we really weren't sure about, despite the fact that, you know, tens, if not hundreds of thousands of people have been on this medicine, we knew that it's gotten to the body and worked on cholesterol. We didn't actually know if it would make it into the brain. And there are actually 3 fibrates that are out there that we could have used. But what we did was we went back to Dr. Nelson and we said, Dr. Nelson, you're a scientist. Which one is most likely to be able to make it into the brain? Because that was what was important for us. So we guessed, you know, with computer simulations and the like, we said Gemfibrozil we think is going to make it into the brain. And it was really overwhelming. So you can see, I showed a little dark blue bar on the placebo, but there was no Gemfibrozil in the brain at all. It was completely zero. And we were able to measure very nice levels of Gemfibrozil that tell us, all right, the medicine's safe. Also, the medicine gets right to where we want it to be, right in the brain, right where the Alzheimer problem occurs. And we began looking at, well, now we've cleared all that out. Did it work? And this is important. As we go into whether or not it worked or not, I do want to remind you a few things. 75 people in a study is an incredibly small study. With that being said, it still cost about $3 million to run that study. It's expensive to run studies. We usually look for a p-value of 0.05, so 0.05 or less for statistical significance. The study was so small, we weren't actually expecting to hit statistical significance with anything. What we were hoping to do was to see evidence of what we call target engagement. Is it doing what we thought it would do? So we measured in the spinal fluid at the beginning and the end microRNA 107 levels. And what we were able to show was that microRNA 107, and these, you'll have to forgive me because of the way that the assays were done, you can think about this graph being flipped upwards. The lower the bar is, the more microRNA 107 was increased in your brain over the course of the clinical trial. So we were quite pleased with that. It showed that we increased microRNA 107 levels in folks on Gemfibrozil. We then went right and looked at Alzheimer proteins, and we looked at these in each and every one of you. What we were hoping was that we would see positive changes on amyloid, the component that makes plaques in the brain, and that's exactly what we saw. We also were hoping that we would see changes, favorable changes, reductions in tau. That's what forms neurofibrillary tangles, and that's exactly what we saw. And frequently to the far right, we make a ratio of these two, and that is clinical, or in the lab, that is one of the lab tests for Alzheimer's disease. Now, nobody in the study had Alzheimer's disease, but each one of us lives our life making a certain amount of Alzheimer proteins, and that can change over time, and we can start moving closer and closer to Alzheimer's disease. The purpose of this study was, can we push people further and further away from Alzheimer's disease? And that's exactly what the study showed. People that were on Gemfibrozil moved further away from Alzheimer's disease and future risk. We also looked at memory over time, and we looked at that with the mini-mental, and we looked at this with what's called the free and cued selective reminding test, and we looked at this on the computerized program. Everybody remember playing the computerized memory testing, right? So I think he was on placebo. Just kidding. And what we found actually was across the board, the trends all moved in favor of Gemfibrozil. People did better, actually improved on their free and cued selective reminding test and on their CANS memory. And when we look at the interaction by arm over time, so that's the true outcome measure. Those numbers are at the very bottom, visit by arm interaction. What we actually found is we actually hit a p-value for memory, despite the fact that it was only 75 people, of less than 0.01. Striking. And for the free and cued selective reminding test, the p-value was 0.086. Not quite our 0.05, but pretty darn good. We also looked at that brain imaging. So when we look at the brain imaging, you know, and I always come out and tell everybody, hey, your brain looked pretty good today, or we saw a little of this or a little bit of that. But in the meanwhile, you know, I have graduate students and they're physicists in the lab, and they are measuring, they have measured your brain. Every millimeter of your brain has been measured. And they looked at a few features. They looked at white matter hyperintensity. This is what we call hardening of the arteries. And there was much less of this in the Gemfibrozil treated group. They looked at shrinkage of the memory areas of the brain, what we call the hippocampus. And that's an area in Alzheimer's disease where the hippocampus really is the first area to really shrink. And what we saw was that the placebo group had normal age-related shrinkage of the hippocampus, a little smaller every year. We almost completely stopped that with Gemfibrozil. 0.15 for a p-value. And ventricular volume change is really an estimate of the size of the brain. So in general, the brain itself shrunk less in those on Gemfibrozil. We also looked at metabolic changes, so fascinating. So in blue is the Gemfibrozil group, and in red, dotted line up above it, and I'm sorry, these are hard to see here. What we saw was that people on Gemfibrozil, their triglyceride levels improved. Their cholesterol levels improved and dropped. Their blood sugar levels improved and dropped, moved people away from type 2 diabetes. And interestingly, we also saw a drop in inflammatory cells, what are called neutrophils. I suspect, and I wonder, when we look at the musculoskeletal aches and pains, they were less in the treated group, whether or not there is an anti-inflammatory component, whether or not Gemfibrozil actually helped with age-related arthritis and the like. We're actually evaluating this currently in a whole separate set of experiments to look at all of those inflammatory mediators. So at the end of the day, we drew several conclusions. We said, first, Gemfibrozil is safe and well tolerated, pennies a day for this medicine. That all of our measures, the microRNA, the tau, the MRI measures, everything moved in the correct and expected direction, showing benefit. We saw clearly, and all of those metabolic improvements in cholesterol, triglyceride, sugar, and inflammatory cells are all statistically significant and positive. So we think this needs to move further. We were able to go back to our statisticians and say, all right, we studied 75 people and we're seeing positive movement, but we didn't hit p-values across the board enough to prove definitively that this works. How many people do we need to study in the future to prove definitively that Gemfibrozil may prevent Alzheimer's disease? And the answers were anywhere from 106 to 224 people per treatment group should give us a positive result and actually get an approval by the FDA for Gemfibrozil to be used for the prevention of Alzheimer's disease. So that's fascinating. So where this is currently, about 3 weeks ago, I submitted a large grant back to the National Institutes of Health to put more of your tax dollars to work for a study of 600 people that will be run nationally across, we estimate, 50 sites, 12 people at each site rather than all 75 coming from UK. And we intend in the next few years to have Gemfibrozil and your research participation on the front page of every major news outlet as one of the first medicines for pennies a day that could treat millions of people, tens of millions, hundreds of millions at risk for Alzheimer's disease across the globe. So that's what comes from the research. So I point out a few folks here. Dr. Pete Nelson, it really was his scientific discovery that led to this. And he was my partner in this, my co-principal investigator. S.C. Ighodaro was his and my graduate student in her MD, PhD years. She was funded by the NIH to explore those metabolic effects. Why did everybody's sugar get better? Why did their cholesterol get better? And Dick Criscio, who's the brains behind it, because I don't understand a darn thing that those statisticians do. Do we have any statisticians in the group? Oh my goodness, it's genius. Anyway, Dick Criscio, and a whole host of the folks that you all interacted with throughout the study as well. So I know that that's technical and a lot of information, but I am so excited and I cannot wait. We will hear we'll hear the first round of whether or not this is moving forward with the proposal I put in 3 weeks ago as early as October, early to mid-October. And then if it's a thumbs up and a go ahead, the trial will start probably within the next year. So moving forward rapidly anyway. But I really want to thank each and every one of you. I cannot, if I could walk into the laboratory, draw my own spinal fluid, it would be difficult. I have donated mine to the center before, but I don't think I could draw it myself. If I could be a research subject and do it all myself, I wouldn't ask anything of you all. But I can't do this alone. This is a team effort, and we all work together on this project. I wish I could include every one of you as a co-author on the scientific paper, which I'm currently writing, but I jumped the gun and wanted to get the grant in first because I don't want to delay that. I can publish the paper after the fact. Unfortunately, I can't disclose your names. I can only put in the acknowledgement section how important your contributions were.